How you doing?
Doing really good. So, welcome everyone. Just a quick intro for this session. This is another fine edition of the Helium Live series. And today we want to dig in to the idea of connectivity rebuilt. So, it's a core interest for Helium, and we're seeing a lot of really other cool stuff happen in the ecosystem. So, introducing Austin Federa. He's former head of strategy at the Solana Foundation and now the co-founder of Double Zero. So to set the stage a little bit, the traditional infrastructure we see as broken. We have a lot of opportunity to take the agency and build these things the way they should have been built in the first place, if in my personal opinion. And so to state the goal, we're helping these listeners, folks watching today, understand what DePIN means, understand what Helium and Double Zero are bringing to the ecosystem, what we're doing, and just I want to dive in and understand. Austin, you have a very unique story getting to this place, so we'll get into that as well. So yeah, welcome to the show.
Hey, thanks for having me.
So let's get right into it. I set the table stakes as I love to do on these. I want to, I guess, hear in your perspective, as you've seen this area evolve, like what is DePIN? Just right. Everyone's got an idea here.
What is DePIN? Okay, so DePIN is either a fairly targeted, fairly narrow category, or it's basically literally everything except NFTs. And this is a thing I have found annoying for years, is there's been this sort of move to define DePIN as basically anything that has token emissions, which I think is not a very helpful way. For me, the P in DePIN is what matters, and physical, right? Mm-hmm. Decentralized physical infrastructure networks. And by physical, we don't mean there's a server somewhere. That's not physical, right? Like there's a lot of things like, and there's nothing against these protocols, but like distributed compute protocols, distributed storage protocols. And a lot of the times when you look at them, the physicality just refers to a server somewhere. And that's a pretty lame definition of DePIN. By that argument, Bitcoin miners are DePIN. Right. And so Bitcoin's a DePIN protocol. And I think we're all like, all right, well, if Bitcoin's a DePIN protocol, is this really a useful category? My answer there would be no. So for me, stuff that actually is proper DePIN is stuff where the physicality, the physical location matters. And so Helium, there's physical limits to the range of a radio. Right? The deployment location matters. If you take that one in your window and you put it under your desk, it'll do worse. If I am in Dubai, it won't do me any good at all, right? There's all, like the physical locations truly matter. That's not true for like IPFS or Akash or something like that, where like the physical location really doesn't matter for the most part. If you look at Double Zero, it is a physical fiber infrastructure network with actual cables running under the oceans and over the mountains and under cities. The physical location of it is paramount. It is literally the point of the network, is the physical presences around the world. And so from that perspective, I think you can look at this and say, yeah, there's DePIN characteristics of the Double Zero network. Otherwise, you get into this definition where Solana is suddenly DePIN because there's physical servers in physical places in the world, and it's a bare metal system, so they're like actually physical dedicated servers, not just virtualized objects. I don't think that's a useful definition of DePIN.
Right. I agree 100%. By the way, so I'm glad you phrased that so well. So for somebody new to DePINs and physical infrastructure, most people don't think about the way they connect, right? So why are we tackling this? Why does it need to be rebuilt?
Yeah, I mean, it depends on the application, right? So if you look at something like a energy network, where what you're talking about there is like a distributed solar system or some sort of like smart grid overlay system, that doesn't necessarily need new forms of connectivity. The public internet actually works really well because none of that data is particularly timely. If you get power generation data or something from one system and it's 2 or 4 seconds delayed, no one really cares at the end of the day because these things already move at the speed of light, speed of electrons through wires, which is going to be faster than communication systems anyway. So it's always a reactive system to some extent. if you're looking at, let me take a step back. So the point of 00 is to build a parallel internet faster than the public internet, using the same technologies and tools that Wall Street and Web2 firms have been using for decades. So blockchain can actually compete with these centralized systems and centralized players. For years, everything we've built on top of blockchain, from Bitcoin to Helium to Solana to Monad, all of this runs over the public internet. And so Helium is an interesting one where the last mile is not over the public internet, it's over the Helium network. But the vast majority of all Helium hotspots, they backhaul via the public internet to talk to one another to get to the places that they need data. This is distinct from what maybe used to be competitors and now are sort of co-collaborators of the traditional telecoms. So like when my data talks to the T-Mobile tower, if it's a T-Mobile tower, it is not backhauling over the public internet. There's a fiber line run to that tower, which then connects in to some other peering system somewhere. And eventually, of course, that data makes it onto the public internet. But it transits through dedicated links before it gets to like a public internet peering point. In some ways, you can think of the theoretical maximum throughput of a Helium hotspot as the public internet backhaul of that hotspot. And for most of us, for 99% of the use cases of Helium network, that is completely fine, because at the end of the day, like what we're doing is we're downloading data, we're transmitting data, all these types of things. The sort of like 5G tech demo videos that you saw back in the day of like, look at this, I'm downloading a 4K movie in 32 seconds, right? Because it's like, I'm holding my phone in the perfect right position on this one street corner in New York City or in this big stadium.
No trees.
There's no trees, there's no nothing. There's no reason Helium couldn't deploy radios that have that same technology in them, but then you'd need like a gigabit or 2 or 5 on the backhaul to actually make that data usable. And so we're sort of in this place across a bunch of areas in the industry where the public internet is the thing that's holding back the aggregate throughput of these new generation systems. On some level, Helium is held back by the public internet. The hotspot in my house definitionally cannot be faster than my public internet connection. Or the hotspot hosted in the Solana office can't be faster than the Solana office's internet connection. And so at some point, and Helium's obviously gotten a huge way using the public internet, but at some point, if Helium is going to not just partner with carriers, but potentially compete with carriers in a more direct fashion, it may need faster connectivity than the public internet can support. And so there's two options here. One is like there's a lot of professional Helium operators out there that might say, I'm going to go buy a 20 gig link because my radios I'm setting up are able to service, I don't know, the tailgating picnic for a major sports stadium. And, that's actually like a great revenue opportunity for me. But that's a very high OpEx and very high CapEx type of activity. And so part of our focus at 00 is creating this new on-demand network that has characteristics very similar to the cloud transformation. So the cloud transformation was not just a change in technology about, suddenly we have hypervisors and we can get these virtualized server instances. It was the idea that like, instead of calling up a guy and waiting 3 weeks to get 40 servers racked in a data center, I could go to Amazon, talk to no one, put in a credit card, and have 40 servers ready to go in 30 seconds. And that was as much a business model transformation as a technology transformation.
Right. You said the cloud transformation, which came a little bit as a catchphrase, right? But it is frankly the Amazonification of our services that we touch, right? When Amazon went down and your Peloton stopped working and your mattress tried to cook you, like that was that was
my favorite, by the way. The 8 Sleeps just like going completely crazy when they lost their controller.
Yeah, I think some people were just absolutely howling over that. But,
I bet, but it's just like,
I don't own one, so I was on the nice side of that one.
But it's like, what a crazy moment to say, like that one feels like a side plot in a Black Mirror episode. Is like, the mattress is all overheated and like someone's house caught on fire. Like that, it's a funny state of affairs we've gotten to in the world today.
Yeah, so it's a really strange butterfly effect.
Yes,
but I think that this really speaks to the ownership layer of this. So like we've had this arc where early internet, you hosted your website out of your home internet, right? JoeyHiller.com, JoeyCool10.com. Don't go look that one up.
There you go.
You had to figure out how to like connect that thing to the internet, get it out there. There was no Amazon to go drop a thing into an S3 bucket, and now you have a website. And we're starting to see a little bit of an arc on the tail end of that, where people are starting to realize that, wow, I put a lot of trust in the centralized service that has been billing me excessively for what is effectively very cheap commodity stuff, right? Like you can buy a hard drive for $20 that has way more storage than you would ever need for a website now, right? Buy 10 of them and have them all redundant. And so what we're seeing, and I think this is sort of summarizing what you were laying out there, is like Helium is this last mile connectivity, or in the case of this guy, the last 300 feet of connectivity, right?
Yep.
Or 800 feet, depends on your conditions. 00 is sort of in this tree of connectivity. It's the trunk. And so if we're looking at the way that all of this stuff distributes out, like we need those leaves out there getting people connected. But at the core level, that connectivity has to be fast and it has to be broad enough to handle all of that traffic. And so that story of the stadium, right, trying to get connected, we actually see that with Helium when people go and convert these international airports and things like that over to leverage Helium.
Yep.
They are not trusting broad public internet. They don't call Comcast and be like, hey, can I have a business line? That's not quite going to cut it when you're handling 20,000 people moving through a place in any given time, watching Netflix because they're bored and waiting for their planes. So that stuff has to be specifically designed for those use cases. And this is where we don't tend to think about it as a consumer. You plug your Eero in at home and you've got internet, you're good to go. It's a very different narrative in the enterprise space. And so that's really what you've been tackling. And I think it's really exciting through tackling it through crypto in this ecosystem where people are really curious and want to understand what's going on. We're sort of pulling the curtain back on everything that's happening without us and starting to ask questions like, should this be done in a better way?
Yeah, it's kind of interesting when you like the airport analogy that you brought up. Like there's this kind of funny moment a few years ago when I was at JFK and all of the Wi-Fi was down for all of JFK, and it was down because there's a fiber line that brought everything in. So you'd be like, oh, the public Wi-Fi is down. Let me go to the lounge and see if their Wi-Fi is working. Nope. Guess what also was down? All the cell phone connectivity in JFK was also down because that same fiber line that fed the Wi-Fi also fed all of the cell towers because it's an airport and you need all these like very regulated cell radios around them. And so it was this kind of very funny moment where everyone was like, I don't know what's going on. Like my hotspot's not working. It's like, yeah, of course your hotspot's not working. It's run on the same cable as the Wi-Fi. And this is kind of like, the piece
and that can
here,
take out entire communities, by the way. Sometimes it's not just airports.
Oh, absolutely. And so this is kind of one of these funny pieces where we think about like, oh, how do these things actually work in practice? And, one of the things we would get all the time is like, oh, well, like 00, like, why are we centralizing the internet? Like, how can you trust 00? Like, isn't the public internet made up of thousands and thousands of companies? And on some level, yes. But on a very real level, it's 10 to 15 companies that control all of the flow of data around the world. And like, that's maybe different from like, my mom was out in Montana for a while and there was this like regional local ISP that only served like 10 communities. And it's like, sure, they're technically part of the public internet, but they just backhaul to someone else, like not even to service all of Montana, let alone the United States. And it all goes back to these tier 1 ISPs at the end of the day. And so the 00 network with 11 independent contributors, and we're nearly at 13 today, actually starts to approach levels of decentralization that can mirror the public internet. Plus, we can provide assurances that you don't have of the public internet, like exactly what path your data is going to take before you send it. We can catch if anyone is interfering with data along the process, if they're selectively holding back data compared to someone else. And all of this is good principles for high performance systems, but it's truly a requirement from a traditional finance perspective. The exchanges pour hundreds of millions of dollars a year into ensuring fairness on their systems. And fairness, blockchain sort of has an abstract sense of fairness, right? We have the fairness of opportunity that anyone can connect in and run a node, but we don't actually have fairness of order execution. If you're trading on Ethereum or Solana or Aptos or Sui or Monad, you are at the whim of what the validator or the block producer is building at a given moment. If exchanges tried to pull that, they would be sued out of existence by everyone who operates on them. They'd run afoul of a bunch of rules and regulations. And so one of the big challenges with traditional finance coming into the crypto space is it's like, why are they not trading on our decentralized exchanges? Well, sure, there might be a regulatory component of there too, but there's no rules. Like, you don't get a parasitic MEV attack on the New York Stock Exchange. Or if you do, there's a whole bunch of regulators that are going to pull your trading licenses for doing something like that.
Interesting. Yeah.
And so one of the main layers, there's a lot of software layers that can address this, but one of the main things is the hardware layer and the physical infrastructure layer, is that if you get a trade to a traditional exchange and somehow that doesn't get filled, there's like, what happened, man? Like, we sent this packet into your network and suddenly it never made it to the order book. Like, there is a whole, like, that is like a notable incident at an exchange where they will investigate where in their system was some data dropped or where did something not work as expected. In crypto, it's like, hey, sorry, the validators decided not to include your transaction in the block, even if you paid the highest fee, right? Because sometimes these things happen. And so there's a lot of this stuff that if we can provide a neutral transport layer that has cryptographic assurances, that has traceability on packet delivery, that then allows protocol designers to build systems in new ways. Because right now, even if you are on Hyperliquid and Hyperliquid enforces cancels getting in before everything else, the validator can always just, oh, sorry, the packet got dropped. And there's no way you can prove that the packet legitimately didn't just get dropped, because that happens all the time on the public internet. And so a lot of these fairness principles go down to the base layer and say, we need to rethink some of these fundamental principles, like from first principles perspective. And the way you would build a global network for high performance financial and non-financial systems like blockchain would not be the way the public internet operates today. And so that's kind of where we started with 00, is start from the first principles. What would this network look like? How do we build something that has sort of the best of TradFi and the best of the principles and values of blockchain baked in at the same time?
Fascinating. So you're gluing together a lot of little pieces that folks may have been exposed to through Reddit and whatever else we see. Like, we've seen these pictures before, at least I have, of these boxes of fiber that are in New York that are designed to add time delay to these trades, and that's to equal out the time it takes for that same message to get across the country, right? And so a bit of what you're talking about is building an infrastructure that can do that implicitly.
So it's actually even more interesting. Those boxes of fiber are not about data moving across the country. They're about data within the same data center.
Right.
Because
but
if I have a
mapping the
50-foot
times,
cable,
right?
Yeah. So it's like everyone has the same length of cable. Because if I have a 50-foot cable to the switch and you have a 25-foot cable to the switch, that is enough. These systems are optimized so much that even that 25 feet of additional cable will give me a systemic disadvantage over you.
Interesting. Okay.
Yeah.
Cool. I don't want to go too deep down the nerd snipe. Yes.
No, totally. But here's what's really interesting, because in the traditional financial markets, networks are externalized. If you think about it, all of the cost of the network is hoisted onto the jump trading and the Citadels of the world and the DRWs of the world, and all the profit is made by the network companies. So, for example, if you're trying to get on the fastest route across the Atlantic, that might be $300,000 a month. And the next fastest route might be $30,000 a month, because that speed delta really matters. But in some ways, you can think about this as almost a failure of NYSE and NASDAQ to not build their own networks and capture some of that value. In some ways, they're non-vertically integrated systems. And so part of our whole proposition here is there are too many places in the world where blockchain infrastructure is run for any one company to have an economic interest in wiring them all up. There's over 300 data centers where Solana validators are run. There's tens of thousands of cities all around the world where Helium nodes are run. It's just infeasible for any company to actually go in and wire these things up. And so
Right.
this is where you start to get infrastructure sharing, and this is where you can bring consortiums and tokens into the mix, because tokens are the unit that creates that alignment. The same way of like, the origin of Helium is a non-crypto IoT company that couldn't get a good faith mesh network working and slapped a token on it, and somehow, and not somehow, but suddenly became this global network phenomenon that like all of these carriers are using. When for years beforehand, the same principle, the same core pitch was literally the same, except it didn't have an alignment mechanism to create alignment between all these different users on a monetary layer.
Right. So let's dive into that a little bit more, because, the way somebody participates in Helium is they buy a hotspot, they set it up, they make sure it's connected to the public internet usually. And now when they do that transport of connectivity for, the folks in the coffee shop outside, that thing gets a reward and it passes through. And so there's a really one-to-one understanding of the utility that this thing is offering and how I get rewarded for it. How does this work for you talked about the 11 contributors on 00 growing to 13. What are they buying? And then how does that reward enter the equation for them?
So if you look at like validators and RPCs, those are basically and traders, those are like the paying customers in our model on 00.
Okay. So if I'm Mert.
Yeah. So if you're Mert and you're running your validator on 00, you are paying 5% of your block rewards to transmit data and receive data through the 00 network, which is a pretty small fee for the type of global network that's provided in here. And then over time, we'll add additional things like one of the major components we've been working on is prioritized data. And so that's the ability to say, we have, maybe it's kind of useful to start here, 00.xyz/dashboard, if you're following along. This is the global fiber map of all of the connections that the 00 network has. And what you'll see is there's multiple ways to get to any one city. And all of those pathways are faster than the public internet, but some of them are extra faster than the public internet. And so if you're a trader trying to land an arbitrage event and you want to pay to send your data more quickly, you can do that. And so that's kind of one of the additional monetization pathways for the network over the long term. I would love to get to a point where validators are barely paying anything to use the network, and the majority of it is paid for by traders and other types of businesses that want to use it. We then take those fees, they're all swapped into the 00 native token, 2Z, and then a portion of those are burned for Sybil resistance, and the rest are distributed out to the network contributors as basically rewards for being part of the protocol. One of the interesting decisions we made is very different from Helium. So Helium has basically passive rewards. If you set up a hotspot, you receive, or at least you used to, you receive a certain amount of tokens, irrespective of if that hotspot is used. 00 does not reward coverage or capacity that is not actually used. So if you put in a fiber line from X location to Y location, and there's no usage of that fiber line, you're actually not going to get paid anything for having that network and that line in place. And so this is part of, we've built this system called proof of utility because the OpEx and CapEx are so high. Helium had this problem in the early days of kind of like phantom mining, where people would sort of pretend they're in a different location than they are to sort of get higher rewards and these sorts of things. Obviously there's a ton of engineering that went into squashing that down and getting rid of that. In our case, because the OpEx and CapEx is so much higher, our policing is actually much easier than with like the Helium network. And so instead, we just don't have a passive reward system on it. So it's just a different model of how to create the same kind of long-term outcome of incentivizing people to deploy infrastructure where infrastructure is needed.
Well, and it sounds, we've had this narrative in the early days of Helium of solving this chicken and egg problem, but it sounds like you've effectively managed to go to market with both your chicken and your egg. And so that, if I'm going to draw a parallel here to Helium, the Mertz, the RPC, he's an easy one to poke at because he's so loud, but right. But he's your AT&T in this narrative, right? He is your
Yep.
customer. He's got people that need to have this service and get their transactions in and all of that. But then the provider is the fiber owner is effectively the hotspot in that narrative, providing that connectivity, very different, right? But making Mert's thing work better. So,
Yeah.
okay.
I mean, and the nice thing here is that there's business, if I can use the S word, there's business synergy around this type of thing. Because you have someone like Helios where they run RPCs, but they also run a validator and they also hold a bunch of SOL. And so if they have this kind of like flywheel effect, and Galaxy is like a great example of this. Galaxy is a network contributor to us. They're contributing fiber. They run one of the largest validators on Solana. They run a market making business. They run a digital asset trading business. There's all of these components where they say, well, our market making will be more profitable and we can quote tighter if all the leaders are connected into 000. And they also say, okay, our validator will be more performant if it's on 000. And they have a thesis that if Solana is doing 100,000 transactions per second, it'll be worth more than it's worth today, which seems like a pretty reasonable thesis to me. And so
Cool.
they can look at all of those and they can say, okay, 000 as a physical infrastructure network is a underpinning of allowing all this other stuff to happen. Magically, if we put our market making activities on 000 or a validator on 000, it doesn't like magically make everything faster, but it gives them a whole new set of base tools and base capabilities to build new stuff. The same way that like, the H100 did not invent ChatGPT, but it certainly wouldn't have been possible without the infrastructure layer investments that NVIDIA had made to actually give us a price per compute number that was low enough that AI could be available to consumers and not just research labs and big companies.
Mm-hmm. Yeah, the ideas of AI are not particularly new, but they are
Right.
actually much more feasible now. So before we jumped on this call, I was kind of quizzing the folks in my workspace here. I was like, what would you want to know about an infrastructure provider? So, if we look at, the impacts of Helium to the average user, they're not thinking about it when they connect to the Helium network. 2 million people do that daily, right?
Yep.
Crazy number. Nobody knows what they're doing out there. The impact for them is better connectivity, maybe a cheaper phone plan. In the case of Helium Mobile, it's connecting those phones for no cost, right? For 000, what is the impact for that average person? And we can take this from like, crypto reaching out into the world as a...
Yeah, it's interesting. So I would say, when you sort of, I guess the impact for the average person is sort of like asking, like, what's the impact for the average person of, a new type of like fiber connectivity coming in, or the 4G to 5G transition or something. A lot of this stuff is not directly apparent on its surface level, but like we can take this we take a few different examples of what this looks like. So one of those examples is the network allows for people to make better types of products on top of it. And so tangibly, what does that mean? Market makers are able to quote tighter. Spreads are thinner in a good way, right? Price is closer to true price. We hopefully move price discovery back on chain away from places like Binance. And a lot of these components at the end of the day, they're all about there's like small level improvements on some components. And then there's also macro level improvements on a bunch of other components. And so this is like, we can make like prop AMMs are more efficient. Spreads are tighter on networks. Like there's all this other types of things. And then the high level stuff of like, okay, Alpenglow can run in a much more efficient way if voter and rotor are multicasted out. And so we have these sort of like small improvements, which will make a difference in everyone's day-to-day trading and day-to-day lives on chain. And then we also have these like larger components, which make a different type of difference. The difference they see in this is a little bit different. But for them, the power of this is really all about the ability to like 10x performance. It's like a whole new tool set for developers. And once they get that, you'll see a lot of downstream benefits.
It's a little bit similar to our narrative. It is going to work better, and you're not going to have to think about it too much, which is actually a
And
huge value prop.
Totally. And I think what's interesting is like, Helium really sits in with the existing cell phone connectivity network, right? And so it's like my incremental connectivity quality goes up, but it's not like, or in like the extreme, it's like I have connectivity somewhere I wouldn't before. I think with 00, the vision and mission behind this is if we make incremental improvements to the quality of service that folks have, that's a little bit of still a failure case for me. I think what we're aiming for is a more wholesale transformation of what's possible, because Helium at the end of the day is like most DePIN is trading off the ability to have a much wider area of coverage for slightly lower quality service. This should surprise no one. A Helium radio is not as good in quotes as like a radio on a major cell phone tower. It's also a few $100s as opposed to a few $100,000. As you mentioned, it's like 800 feet of range, not like a few miles of range, but you can deploy it instantly. It doesn't take 2 years of permitting to get that tower up and built. So there's a really like tangible value to performance trade-off, which is totally worth it. For 00, we have a smaller reach than the public internet, but we're higher quality than the public internet. So it's almost like you can think about it as the exact opposite paradigm and value proposition of Helium, which is like Helium, anyone can deploy it, coverage everywhere. Each individual radio is worse than a cell tower, but in aggregate, you make up something that's quite impressive. 00, like you will never get 00 service into your home, at least not in any foreseeable, future. But the trade-off for that is now you have much more performant systems operating in other areas.
Right. Yeah, you gain a lot of operational efficiency and quality through focus in a sense. Yeah. Cool. So I guess my last question, we're running a little over time. Hopefully I can keep you here for a sec. For the average person coming back to me, right? There's the 00 token, there's the RPC providers. You can sort of vote in your choice of RPC provider to use if you're building a protocol or a tool on Solana or another network using 00. What is frankly, what is the best way for me, right, to get involved with 00?
So it depends sort of how you're looking to get involved. So if you are someone who has access to a potential fiber line or something like that, we'd love to chat. I think that's a big area for us where, we're onboarding new network contributors every day. If you have, let's say if you are a validator on Solana, or if you're building some other type of system, we would love to work with you on these types of things as well. I think that's another big area for us. And the last one is if you're building some type of new network or working on some type of other system, we would love to chat as well, because there's other new layer 1s and layer 2s or even non-blockchain systems we're working with. And from day one, they can target like 100 gigabits per second of capacity. That's very interesting for them too.
Cool.
Yeah.
Awesome. Well, Austin, this was a really fun chat. I hopefully we didn't go too nerdy for the folks watching, but if folks have questions, they should reach out to you. There's the 00 handle at 00. I think your handle is Austin_Federa on Twitter.
That's correct.
So seek you there. I'm at jhiller. Any questions about Helium, I'm there all day long. Let's keep building the future of connectivity in the way that we want to see it done.
Love it.
Cool. All right. Thank you.
Thanks.